Watson and Crick Structure of DNA by Jessica Beltrani. The main findings of this experiment was that Watson and Crick determined the structure of DNA. They found that DNA is composed of two strands of anti-parallel nucleotides forming a right-handed double helix. There are nitrogenous bases on the inside and a sugar-phosphate backbone. As stated, DNA is made up of 4 nitrogenous bases. There are purines, which are adenine and guanine, and there are pyrimidines, which are thymine and cytosine. Base pairing allows for a constant width of the double helix structure. Each nucleotide pairs with another specific nucleotide. Adenine pairs with thymine, and guanine pairs with cytosine. They are held together by hydrogen bonds. Nitrogenous bases hold the genetic material and act as information carriers of the DNA. Adenine and thymine use 2 hydrogen bonds, and guanine and cytosine use 3 hydrogen bonds, giving it a stronger pairing. Hydrogen bonds are weak interactions, but they are not the main force in joining 2 strands of DNA. However, they are the main force in stabilizing the double helix structure. They make it so adenine has to pair with thymine and guanine has to pair with cytosine. They are maximized by perpendicular nitrogenous base stacking, as the bases are perpendicular to the phosphate backbone, maximizing the amount of hydrogen bonds in the DNA. Hydrogen bonds are needed for certain DNA functions, as the weak hydrogen bond is easy to break. The phosphate backbone is composed of a phosphate group and a deoxyribose sugar. The phosphate group has a negative charge, which gives DNA a slightly negative charge, making it acidic. They are held together by phosphodiester bonds. Phosphodiester bonds are strong covalent bonds that join the 5' phosphate group of one nucleotide to the 3' hydroxyl group of the next nucleotide. Deoxyribose sugar is a 5-carbon sugar found in the backbone of DNA. It is less reactive and more stable than ribose found in RNA, making it better for storing long-term genetic information. Here's our 5-carbon deoxyribose sugar. We have the 1' carbon, which has the nitrogenous base, 2' carbon, which makes it a DNA and not an RNA because it has the H and not the OH. Our 5' carbon has the phosphate group, and the 3' also bonds to another phosphate group. bDNA is the secondary or 3D structure described by Watson and Crick. They found that DNA is composed of 10 base pairs per 360-degree helix rotation. They found that it was a clockwise rotation, making it right-handed. They found this bDNA structure is the most stable configuration and predominant structure in the cell, as it exists when water is most abundant. This would be a major groove of DNA, and this would be a minor groove. Regarding handedness, they knew that it was a clockwise rotation, so it goes up right-handed. Regarding handedness, these are some pictures of left-handed DNA that I found in the media. They all go at a counterclockwise rotation, and they go up and towards the left, like so, like so.